For this particular lesson, we're going to discuss the symmetry of graphs of functions that you could see. Now, there's two main types of functions, or excuse me, two types of symmetry that we're going to deal with here mostly, and that's point symmetry, which is when a graph is reflected across an entire point, and then we're going to be dealing with line symmetry later on in the lesson, when a graph is reflected across a particular line. Now, different types of graphs have different types of symmetry, or they have no symmetry at all. So we just want to use this as a means of identification and become comfortable with this. Now, we've kind of started discussion of reflecting and flipping graphs over various points and lines up at this point, but now we need to dig in a little deep. We'll start off our discussion with point symmetry, and you can see that we have some images that are just representative of values on a plane that are reflected around a given point. And so if they're reflected across a point, they have their image point on the other side, and you can see a geometric shape, a line, and you can also see the graph of a function in the examples given. Now, the most common point of symmetry is the origin, and so we're going to discuss how we come up with knowing whether the origin is a point of symmetry or not. So if we look at this first example, it says to look at the pattern of the table of functions, the table of function values for f of x equals 3. Now, if you notice, when filling in these functions, what you're going to basically see is this. You're going to see f of x is our standard parent function, and I apologize if this thing moves around a little bit. I had some trouble with it earlier, but you can see our standard cubic function looks something like this. So that's f of x. Now, what I'd like to do is I'd like to go just to the calculator and then actually graph f of negative x, and so that means that I'm going to use parentheses, and I'm going to use the little negative x, close parentheses, raised to the third, and I'm going to hit enter, and you can see that that kind of flips our graph around. Now, according to our table of values here, it looks as if the negative of that should be the same thing. So I'm going to try that again. So here, what I'm going to do this time instead, I'm going to do negative, and in the parentheses I'm going to put x raised to the third power, and I want to see if that gives me the same thing, and it absolutely does. Kind of hard to see. I'm going to drag that out a little bit, but you can see that it overlays each other on the graph, and so that would basically mean here that on this other side I have two functions. I have f and negative x, and I have negative f of x, and showing that those two equal. Now, what that means is if those two functions equal, we are dealing with a graph that has point symmetry, and more specifically point symmetry with respect to the origin. So this is a good test. Now, we had you graph it on a coordinate plane here with table of values, but obviously the quick way would be just to simply move to your graphing calculator. So if we look at the next one on the following page, it asks us to check the following on our calculator as well. And so I'm just going to graph g of x first on the calculator, and I'm just going to clear this out. And so we have 1 over x, and so I just do 1 divided by x, and I hit enter. And you can see that we have these two graphs that never touch each other. Okay, and you can see the reflection that's across the origin here. Now, this is much easier to tell visually than mathematically. So if I'm graphing that, I'm simply saying that this is coming through roughly at about 1 and -1, and we'll get to this graphing technique later. And again, I apologize if the graph's moving around on you. Now, we can check this for symmetry simply by graphing the negatives of this, the g of -x. So I'm going to try that. So g of -x would be 1 divided by, and in parentheses, a -x. And so that would give me that graph. Now, other than just looking at it, I know that this will be point symmetry with respect to the origin if the negative function is the same. So this time I'm going to put -1 divided by x and hit enter, and of course we have the same graph, and it just overlays the top of that. And so that tells us very clearly that this graph has point symmetry with respect to the origin. So that's just a quick, easy way for you to determine mathematically if a function is symmetric with respect to the origin, and of course you can see through the graphical or the visual way to tell that as well.